All right, here's a few more problems on finding the 6 trig values. So this time in the problems that I'm given, no triangle is given to me. All I'm told is one of the trig functions and its value. So in this problem, it tells me that the sine of theta equals 3 over 4. Well, because I know that the sine of an angle is the opposite over the hypotenuse, I know that 3 represents the opposite and 4 represents the hypotenuse. So if I draw myself the triangle, or any triangle, I can pick my theta. I generally like to pick this down here as my theta. And again, I know that the opposite is 3 and the hypotenuse is 4. So the opposite side to this angle is 3 and the hypotenuse, oops, I didn't label my triangle as being right, but my hypotenuse is 4. So now I've got to go on and figure out my adjacent side length, because that was not given to me. All right, this is the opposite, this is the hypotenuse, and this is the adjacent. But I don't know the adjacent value. So once again, I'm going to go back to the Pythagorean theorem, which is how I solve for the third side of a right triangle. And I'm going to call the adjacent A. So A squared plus 3 squared equals 4 squared. So A squared plus 9 equals 16. When I subtract 9 from both sides, I get that A squared equals 7. So A equals the square root of 7. Not the prettiest number in the world, but I can deal with it. So A equals the square root of 7. So I'm going to fill that out in my triangle up here. Oops. Coming back to my triangle, I'm going to put the square root of 7 because I've now solved for that. Now I know all of the sides of the triangle. I was already given sine, so I need to figure out what the cosine of theta is, the tangent of theta, and then the cosecant, the secant, and the tangent. Whoops, not the tangent, the cotangent. All right, well, the cosine is adjacent over hypotenuse, so that's root 7 over 4, and the tangent is opposite over adjacent, so that's equal to 3 over root 7. Now, most teachers like it when we rationalize, so I'm going to do that in this problem. I'm going to multiply both the top and the bottom by root 7 because root 7 times root 7 is 7. Now I have a whole number on the bottom, and in the numerator I have 3 root 7 over 7. So that's the answer that would probably be found in the back of a book. The cosecant, remember, is the reciprocal of sine. So if sine was 3 over 4, then cosecant must be 4 over 3. Secant is the inverse of cosine. So if it was root 7 over 4, then this is 4 over root 7. And here I am again with a radical in my denominator, so I'm going to rationalize that by multiplying the top and the bottom by root 7. I get 7, 4 root 7 over 7. And my cotangent, I'm actually going to use the original because when I flip that, the root 7 is going to end up on the top and the 3 is going to end up on the bottom. And therefore, I don't have to work with this really crazy, ugly number there. All right. In my next problem that I was given, they told me that the secant of theta is equal to 2. Okay, well, I know that 2 is 2 over 1. So if I know that the secant of theta is 2 over 1, well, I don't usually use secant that much, but I do know that secant is the reciprocal of cosine. So if I know that the secant is 2 over 1, because here, I'll set this up. I've got the sine of theta, I've got the cosine of theta, I've got the tangent, and then I've got the cosecant, the secant, and the cotangent. So if I know that the secant is 2 over 1, then my cosine must be 1 over 2, and I like that a lot better. I just feel better working with cosine than I do with secant. So again, I'm going to draw a right triangle. I always tend to draw them like this because I'm just so adopted to my first quadrant right triangles. There's my right angle. I'm going to call this my theta. And so cosine is, well, this is the opposite side. Let's go over everything. This is the hypotenuse and this is the adjacent, right? To this theta, this one right here. All right, if cosine is 1 over 2 and cosine is adjacent over hypotenuse, a over h, then my adjacent side has to have a value of 1 and my hypotenuse has to have a value of 2. So how big is my opposite side? Well, again, I'm going to use the Pythagorean theorem. I'll call this b, and I'll say that 1 squared plus b squared equals 2 squared. 1 plus b squared equals 4. I subtract 1 from both sides. I'm running out of room, so I'll go right over here. B squared equals 3. So b equals the square root of 3. So this side value is the square root of 3. Now I have all of my sides. So now I know that sine SOHCAHTOA is opposite over hypotenuse. So that's root 3 over 2. Let me put the 2 here nice and big. My tangent is opposite over adjacent. So that's root 3 over 1 or just root 3. My cosecant is the inverse, or excuse me, the reciprocal of sine. So it's 2 over root 3. And I'm going to need to rationalize that, so I'm going to make a little room here. I'm going to multiply both the top and bottom by root 3 over 3 because it's the same as multiplying by 1. And I get 2 root 3 over 3. So that's the official answer for cosecant, which is probably what I'd find in the back of my book. Secant was given to me, remember, 2 over 1, so I get lucky I don't have to do that. And cotangent is the reciprocal of tangent. Now, I didn't write the 1 here, but I kind of need it now because it's 1 over root 3, and I need to rationalize this one as well. Root 3 over 3. So the cotangent is root 3 over 3. That's this one. All right, the next problem that my book gives me says that the tangent of theta equals 3. So I'm going to make my whole thing here sine, cosine. I should probably just copy this and use it over and over again, but cosecant, secant, and cotangent. So I've got to solve for all of these, and the one that I'm given is tangent, being 3. So I'm going to fill that out. It's 3, or 3 over 1 if I want to write that to make it easier. Oh, so without even having to do anything, I know that my cotangent is 1 over 3. That was easy. I'm going to go ahead and draw a right triangle. I'll draw it down here. And I'm going to be a little crazy. I'm going to do it a little different this time. I'm going to put my theta up here. Okay, here's my right triangle. So now if this is my theta, then this is my opposite side. This is my adjacent side. And always the hypotenuse is across from the right angle. Now from up here, I learned that the tangent is 3 over 1. And tangent is always from SOHCAHTOA, opposite over adjacent. So it's the opposite side is 3 and the adjacent side is 1. Opposite side is 3, adjacent side has a value of 1. So I need to solve for my hypotenuse. Again, a squared plus b squared equals c squared, so I get 3 squared plus 1 squared equals c squared. I'm using the Pythagorean theorem. 9 plus 1 equals c squared. 10 equals c squared. I take the square root of both sides and I get that the square root of 10 equals c. So my hypotenuse has a value of the square root of 10. Okay, I've now filled out my triangle and I can evaluate all of my trig functions now with this triangle. Now don't be confused because I put theta in a different spot. It doesn't matter where I put it. As long as I don't put it on the right angle, I'm good to go. So sine is opposite over hypotenuse. So now this is my opposite side down here, and my hypotenuse is root 10. So this is 3 over root 10, and I would have to rationalize that to be 3 root 10 over 10. My cosine is adjacent over hypotenuse, so it's 1 over root 10, which once rationalized is root 10 over 10. And then I'm going to use my reciprocals to solve for the cosecant, the secant, and the cotangent. So if this value was my sine right here, then the reciprocal of that is my cosecant. If this was my original cosine before I rationalized it, then that's my secant, and I'm done. Yellow.